Hi, today we're going to learn about a useful property called density. Density, like color or hardness, is a physical property that allows us to figure out what stuff is or made of. So, what exactly is density? One way we can look at it is basically how much stuff there is in some amount of space we have. So here we have the stuff, and it's within a defined amount of space, shown by the red box. And from that definition, we can look at it from two perspectives. That stuff could be rather large, like people, for example. We can say the subway car in Japan is denser than, let's say, your classroom. However, for this video, what we're going to talk about refers to the very small particles we learned about last time. So now, a question to think about during this video. If we fill one balloon with helium, and we fill a second balloon with water, which one of the two would be denser? Now, some of you probably aren't satisfied with my definition. Density, while I express it in words, it's almost always represented as a value. So, if we go back to my first definition, density is the amount of stuff compared to the amount of space we have. So it's the stuff over the amount of space. Now, from a scientific perspective, the stuff is what we'd call mass. And that would be something in like kilograms, for example. Mass would be in kilograms. The space is called the volume, and this value would be in something like meters cubed, for example. Thus, the equation for density is mass over volume. Mass over volume. And in this case, the units would be kilograms per meter cubed.
So now that you know what density is, let's try a question. If we fill a 3-liter beaker half full with a liquid, just like that, and put it on a scale, it weighs 0.95 kilograms. The beaker itself weighs 0.5 kilograms. Now, calculate the density of the liquid. So, first, we'll set up our equation for the density. So, density equals mass over volume. Let's start with the mass. The beaker and the liquid weigh 0.95 kilograms together, and the beaker itself weighs 0.5 kilograms. So the difference of mass is the mass of the liquid. So 0.45 kilograms. Now the volume. We know that the beaker is 3 liters, and it's only filled halfway. So the volume of the liquid would be 3 divided by 2, so 1.5 liters. So our density is 0.54 kilograms divided by 1.5 liters, which equals 0.3 kilograms per liter.
So now that we know about density, why is it useful to us? Well, if we know the density of the object, we can explain a lot of things on how that object interacts with the Earth. So, for example, density gets these bragging rights as a property independent of size. Independent of size. So, for example, if I have a drop of water and a bucket of water, their density is still the same, because since density is just a ratio between mass and volume. Density can also tell us how pure a substance is. Let's just say we have a glass of water, and we want to know whether this water is pure water or something's been mixed in or not. Now, water gets this really, really cool density of 1 kilogram per liter. 1 kilogram per liter. And to make sure that it is actually pure water, we could take a sample of this water, and if we know the volume and its weight, we can use that formula to figure out density. And if that density is greater than 1 kilogram per liter, then we know for sure that there must have been something mixed into that water.
Now let's think about density in terms of liquids, solids, and gases. Normally, solids are denser than liquids, and liquids are denser than gases. The particle theory can help us explain this. According to the particle theory, the particles in solids are packed closer together and have strong bonds between them, like this. In liquids, the particles are a little more far apart and have more movement. And in gases, there's lots of space between the particles, and they can move as much as they want. Just like that. As you can see, solids are more dense than liquids because their particles are closer together. And the liquids, likewise, are more dense than the gases. This is the reason why solids are generally denser than liquids and gases. Of course, there are some exceptions, such as ice, which is less dense than water, and liquid mercury can actually be denser than some solids.
Alright, well this concludes our video. I hope you've learned something today. So now we just have some questions to make sure that you've grasped these concepts of density. So the first question we have, as we can see here, we have a white box surrounding a green box. And what's given to you is the density of the green box, and the dimensions of the green box, and the dimensions of the white box, and the total mass of everything. So your job is to find the density of the white volume. Our second question refers back to the beginning of this video, and that's our two balloons, one made of helium and one made of water. And I'm just going to color this nice blue water in. Using your knowledge of particle theory and density, which one is more dense?